So hello and welcome into today's webcast for Electra, an overhead power line design software produced by CGS Plus. My name is Leon Leban and I'll just guide you through the overview of the Electra features that are present. So first, let's start with the platforms, the CAD platforms that are supported. Electra runs on top of Autodesk, AutoCAD, and AutoCAD Civil 3D, but also AutoCAD Map platforms from the latest 2016 down to 2011, and also on the BricsCAD platforms from version 15 down to version 13. So combining Electra with BricsCAD just makes it even more cost-effective for customers and clients needing a software for doing an overhead power line design. For start, let's have a brief introduction with a video, and we'll continue then afterwards, more details. Okay, so much for the introduction to Electra. Let's go now in details. As seen in the video, Electra has an integrated tool for digital terrain modeling. So it is available for users running Electra on top of AutoCAD or BricsCAD, where there's no digital terrain feature or tool available. So for Electra comes with it. In case running on map or with some other functionalities on top of CAD or BricsCAD, there's a possibility to add additional cadastral information, but also some additional infrastructure information. In this example, here's the underground network of power lines in the area that has been put into the drawing. And based on this layout, now an overhead power line, a new power line is going to be designed. And as seen here, first user defines a new alignment, so a new power line. It defines the name of the power line, and in the same step it defines the surface to which the power line will be automatically projected to. So basically, when that power line has been drawn, it's everything set to go to the profile, as we'll see later. But what's also important here is that in the parameters for this power line, also the wind loads can be added, and those wind loads are read from the table that are within the standards which are included in the Electra. So user selects appropriate standard, defines the proper wind zones and length category, and then those values are automatically taken in consideration for the wind loads calculation. So after the power line has been designed, a profile gets drawn, and what's important is that all the masts, so the poles which are on the beginning of the power line and at the end, and all the poles where this power line has a PI, so it has an angle. All these poles are automatically defined already and are inserted in the profile. So user just needs to add the poles in between of those poles. Also, user defines the cables that are attached to those poles, and there is a predefined list of cables. So it's already available in Electra, but users can also add their own cables and define the parameters for those cables. Users can define the maximum tension value, the base temperature, and also the load factor. So that's the winter load in this example. Okay, when this is set, everything is done then and gets calculated. And if user changes the position of the power line in layout, then the profile gets automatically and dynamically updated. Electra provides all the necessary tools to inspect safety distance, either between the conductor and the terrain line, between the conductor and any objects that are on the terrain, but also in between the two conductors that are added, or there are maybe more conductors on the same poles, and those distances can be checked. There are functions for dimensioning, annotations, etc. So all of that can be added to the profile section. There is additional functionality for the crossings analyzing. So whenever a power line crosses another power line or another infrastructure object done by CGS Plus software, Electra finds all those crossings and defines them and shows them in the profile section. So here's a crossing with another power line, and the two conductors which are attached to that power line are shown here with the exact elevation. So now the interference between the, let's say, between the lower cable on the first power line and the upper cable on the second power line can be inspected. But then there's a rail track in one part, and also the distance between, let's say, between this rail track and especially the envelope of the rail vehicle, and the cable can be inspected. Okay. At the end, Electra produces reports for all the conductors that are attached to the poles, with all the parameters of the sag from -20 degrees to +40 degrees, with all the needed values which are calculated so that designers get all necessary information about the sex. Okay, so here's another video that will just guide us through what has been just presented. So first, here it's how we get to the Electra ribbon. We start a project. We'll now define our power line. So yes, in this example, so there were two drawings. In one, there is already a surface. In case we don't have it, we can build it from a survey points or from other elements like polylines, blocks, etc. So when we have a DTM, so we'll switch now to the other drawing. When we have the DTM, now we can start with the designing of the power line. Okay, so there's just additional layers for the cadastral information and existing infrastructure. So now we go to Axis Manager. Here all the power lines are defined and we can add more. So just by defining new axis, we can define new power line that will be designed. We give it a name. Click OK. And then when we start designing it, we define, so we can change so for which power line we will be drawing. It is always on the last one that we have set. Now just define the starting position of this power line. Here we'll do an angle and then the finish point of this power line. So everything was now prepared for the profile. We just insert this terrain to a profile view table. And as seen here, so the first pole, the pole at the angle, and the pole at the end have been added to the profile. And then if we move the power line, the profile gets automatically updated. Then we will just add a conductor to that pole. We go to the catenary. There's a list of conductors. We select one, define all other parameters if where needed and which are needed. Okay, and then just define the height, the attaching point to the pole of this conductor, and then we are just adding in additional poles. Okay, so in the next section, here's another conductor, and as seen here, we just need to add some poles here. So we will put some support poles, and as seen, as we move in the profile, the preview of the catenary seg is already seen. Okay, and if we stop here for a moment, I'd just like to comment. So all the examples that we had from our existing clients for what Electra was used for. So it was not used just for electric cables. It was used also for optical cables, but also for cableways or ski lifts design. So the seg for those cables is very similar. So Electra was used also for that kind of projects, just for, let's say, for the sake of interest. Okay, so let's continue. We will add here some additional poles. Okay, we can change the station of the pole to be on the exact location. But what's more is, so here an example was that we could define the position of the pole and change the location of the pole in profile. But there's even more. Okay, so also, yeah, other parameters like height, but there's more. So we can change the position of the pole in layout as well. So sometimes we need to put it on the exact location because it might be located on a part of land where we are not allowed to put it. So basically, user has the possibility to define the position of that pole in layout as well, and it is automatically adjusted in the profile area. Okay, so in this case we had one conductor, and we will now add additional one, so we will have more cables attached to a specific pole. Okay, what we need is just to define the attaching point, the height of the attachment for this cable. Okay, so it will be 1 meter of this difference between those two cables. And now we can see in the bands, the height of those bands is automatically adjusted depending on the number of, let's say, of the poles that we have. So we will be now adding the third conductor here, the third cable, and you will see that putting on the 8 meter and just be so in the area for the poles, the height of this band has been automatically adjusted for the number of data that's needed. Okay. What's more, so we can now set the checking height. So we are now interested for the lowest cable, if it meets the requirement that it is at least 6 meters above the ground. So the red line defines where those 6 meters are. So they are all above ground, so we are safe. But also we can inspect the heights between two cables. In this case, between the upper cable and the middle one, and we can see by the line that there is not enough. There's not enough distance between those two cables, so we might need to change the attaching point height on the poles. Then what we can do is also we can inspect those safety height between the cables and the terrain and label it in the bands below, and at the end we can produce the report with all the secs containing all the data for all cables that were used, all the cables, all the temperatures and the secs which occur at specific temperatures of the air. Okay, so at the end I would like to invite you to our webpage, cgsplus.com, where you can get even more information, download our brochures, but also get in contact with us within the inquiry that you can set, and we'll provide you all the details further on. So thank you for today, and goodbye.